All right, here's another problem from the Purdue 2014 programming competition, the OneTimePad Part 2. OneTimePad Part 1 was pretty quick to go through. OneTimePad Part 2 makes my brain hurt constantly. It's a great problem. It's really difficult to do without a lot of very careful thought. So the problem sets up that you've got a coach at Indiana who's sending his messages to somebody else secretly and using a one-time pad, but we know somehow that Indiana's coach's keyboard sticks when he types in T, so sometimes two T's show up. And then he resends the message when he sees that he's sent two T's because he's a perfectionist, I guess. And when the second message gets sent, it'll be one letter short. With that information, we will have enough to crack his code and figure out what his message is so that the Purdue defense can be ready. My guess is that they didn't actually do this because Purdue just lost to Indiana yesterday. So uh, if we had actually shared this information, they might have won, but unfortunately we did not. So here's the input format, which will make things make a little bit more sense. So here you can see the first message that's sent. It's encoded nicely in numbers, possible to read unless you have the key. But unfortunately, he's typed in T twice. Now we don't know where it is, but when he sends the message the second time, we can figure that out because here you can see there are two matching sixes, zeros, 18s, and 28s. But after the two matching sixes is a difference. And what that means is in the first message, this is where the second T would be. And this would be then the correct next letter as opposed to a double T. So the length here, just to show you, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But the length of this one is 14. So this is the message sent with a double T. This is the one without the double T. And because this is the first difference, this is where we don't have a T. Here's where we do have a T. So T, 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 no T. Okay, so I've typed up all of the code because if I tried to type this from scratch, I would lose my mind. So here is the code. To begin with, you're going to read in the two different encoded messages, one with a double T, one with not. Message has the two T's, message 2 does not. They're all numeric values, and message will be length 1 more than message 2. I go through and I split them, each of the lines, so I have an array of each of the individual numbers. And then I also make a character array, and I don't know if I needed to make it a character array, but that's what I've done. An array of characters or chars and appropriate links, and then I go through and I take all of the different numeric values that are in the message string. I convert them, interpret them as integers, and then convert them to chars, and then store them in the arrays. Think about that for a little minute. It does make some sense. I'm going through and taking, so let's say it was 123 and 40 here was what was read in. I split this into an array, so now I have the strings 123 and 40. I then, for each of those, convert them to an integer, 123, then convert them to a character and store them in the array. So it will work. It's a little bit crazy. Uh, I don't know if I needed to convert them to chars. That might be an extra step that you can think about whether or not that was necessary. Um, Now I create this thing here, which is a little bit weird. I'm not even sure why I'm doing this, but the directions say I need to. So I need to be printing out the information up to the right before the T's, essentially. So here I have the first pair of T's and then another T. I need everything up to there. So that's what my array list is for, so I can print out this information, and I'm going to hold each of those numbers. So next thing I'm going to do is go through the message string, which is going to be one longer than message 2, so that could be scary, but it's not going to be a problem because we know there's going to be that duplication of T's that's going to allow me to do some shifting and not go out of bounds, which we'll see momentarily. And I get out the characters that are at the two spots, and if they're the same in both of the messages, then I just need to add it to the ciphertext. So I'm just going to keep accumulating them. And then that's all the loop does while they match. When it doesn't match, since I found the first difference, this code here is going to print out correctly the first numbers that were found up to the first T. So here you can see that I'm going through everything but the last one because for some reason it doesn't want the t number. So going back to the directions again, even though these two match, the 6 doesn't show up in the output, so I need to exclude the last value. So I do that. I print out each of the different values in the array list, the number values, and I also put in spaces as well between each of them, but not the last one. So I'm doing a fence post algorithm correctly, then I print a new line so everything else would be on the next line. Okay, so here becomes I have to do a lot of explanations to get this to make sense. So at this part in the program, we have found that at position I, we have something that does not match. So at position I minus 1, we know that we have two t's. So that's what my table is showing you here. We don't know what the encryption key is. We do know that at position I minus 1, they've typed in a t, and then in position I minus 1 in message 2, he also typed in a t. At position I in the message, so the next one, he typed in t again because he has the sticky key, which generated a 0. We don't know what he typed in for the second message, but we do know that number turns out to be a 21. So that's what we have going on so far. So here's the magic. So because we know he typed in a t here, we know that whatever the key is, if you XOR it with the t, you're going to get 0. So for message 1, if you take t, what he typed in, XOR it with a key that we don't know, we're going to get the value of 0. Because of the way XOR operators work, if you do t XOR 0, that'll also give you the key. So now we have a formula for figuring out what the ith key is, key I. Well, now that we know what key I is, we can also use it down here because we don't know what he typed in. But if you XOR it with key I, which we just calculated, that'll give you this number. So if you rearrange it, key I XOR 21 will give you this missing piece of information. So after all of that is done, we will know what this letter is. The reason why this helps us solve the rest of the problem is once you know what this letter is, that tells you what this letter is because you know everything is just shifted over by 1. So after we find out this letter, we put this here, and then we repeat the process. This value XORed with the key of I plus 1 should give you the message, and then that allows you to solve for the key, and then whatever he typed in here XORed with the key should give you 13, so you can solve for this, which gives you that value, and it just keeps going down the line. So hopefully that made some sense, because here comes the code, which isn't long, there's a lot of stuff going on here. So the first thing is we need to keep track of what the current letter was. So we know that we're on a T right now, and we know that we're going to have to print that out. So I print out the fact that we found a T. Then I'm going to loop through almost the entire message. I don't want to go all the way to the end, but I start at position I going forward, and then I apply the formula that we just discussed. So if you take message chars of J, because I'm going through the string forward, and XOR it with the current letter, that'll give me the key. And then if I go to message 2 and XOR it with a key, that'll give me the next current letter. And then I print that out. And then it keeps going until it gets to the end, and then yay, I get done. That's it. That's all the code is. It took me a little while to get the bounds right and to make sure that I was actually implementing the algorithm that I described correctly. But this is code that will correctly implement the algorithm. You'll notice I have to do a break here at the end because I need the outside loop, which you've probably forgotten about at this point. There was a loop here which was going through every position in the message, trying to accumulate ciphertext. But when I got to the point where where I got into the else case, I was kind of starting my own loop to go through the rest of the message, so I wanted to break out of the other loop so I didn't keep going further. Probably a better way to do this was to break the loop and to put all this code outside of the outer loop. I don't know, it's kind of however you want to do it. But this code definitely seems to work. To prove it to you, or at least show you that I matched their code, input-output. If I run it, I put in their example, and yay, it worked. So we have figured out how to decode the Indiana football coach's message by using some handy shifting of the XOR operator. If you have questions about this, let me know. We can talk about it further. It is a fairly complex idea. So yeah, that's it.